So tonight we're going to continue with drill project 3. On my screen, you see the Mastercam file for drill project 3 at the level of completion where we left off last class. I'm looking at the toolpath manager. I can see that I've brought in the machine definitions. I've made the necessary changes to the machine definition. And I've also created the first stock model, the stock model that represents our material. If I make it visible, you can see the gray representation of our material. I'll toggle off the visibility. So from here, I'll go back to the project page, and this is where we left off. We were creating toolpaths. We've already completed steps 1 and 2. We're now moving on to step 3. Use the drill toolpath to create pilots for all through holes on the part. To do that, go back into Mastercam. From the toolpaths tab, go to the 2D section and select drill. I select that icon. You see the toolpath appear in the toolpath manager, and now we're looking at the parameters for that particular toolpath. Now, toolpath hole definition. This is where we select the holes that need to be drilled. Mastercam is prompting us. It says select one or more entities to add or remove from the feature list. There's some other instructions, but in this case, what I'm going to do, I'm going to use this icon right here. It says mask on arc. I'll select it. Now Mastercam is asking me to select an arc to match. If I select this circle right here, the top circle on the top face of the part, and what I'll do is I'll select the one that's closest to the origin. I'll select this circle right here. I scroll my cursor, or I position my cursor over it. It changes to this highlighted dashed glowing effect, indicating if I left click on it, it will become selected. So left click. Mastercam is now prompting me, use window select, Control A, or the quick mask to find matching arcs. I like using the quick mask icon right here, or you could hit Control A, or you could just do a window select over the holes. And then once you do that, you'll see points appear at the center of the selected holes, and then you'll see lines connecting the points. The points should show us the center of the holes being drilled. Then the lines show us the order that the holes are being drilled. The red point tells us which hole will be drilled first. And then all of that information appears in this field over here. If you don't like the order that these holes are being drilled in, what you can do is you can scroll down here where it says sort, expand this menu. I'm going to use this option right here, X zig negative, Y negative. I select it. You can now see that the first hole to be drilled is closest to the origin. And you can see the order that the holes will be drilled in. So once you get that set the way you like it, select OK. And that brings up the parameters for this drilling operation. I'll start by going to the tool. You see our tool list. Currently, we do not have any tools in our tool list. I'll select the select library tool icon. It brings up the tool library. Now I have my filter active, so I'm only seeing one tool at this time. If I select the filter icon, it brings up the tool list filter. Now in most cases, when you open this up, you'll see all tool types selected. I'll start by selecting none. That deselects all tool types. And then I'll select the type of tool that I'm looking for. And in this case, I'm looking for a spot drill. So this icon right here, spot drill. Left click on it. And then in the tool diameter field, I'll expand this menu. I'll set it to ignore. And that will show me all spot drills that are coming out of this library. I'll select OK. There are 6 tools to choose from. We're going to select the 1/2-inch diameter spot drill. If I go back to the project page and scroll all the way to the bottom, you'll find the tool list that we're instructed to use. Tool 1 is going to be a 1/2-inch diameter spot drill, 90-degree DPA, that's drill point angle. And then we're told what type of tool holder to use. So C4C3-0032. And we're going to have the tool sticking out of the collet 1.5 inches. So I'll go back to Mastercam. I'll select the 1/2-inch diameter spot drill. You'll notice that it's tool number 24 coming out of the library. When I select OK, watch what happens. It's added to our tool list as tool number 1. Reason being, when we were bringing in the machine definition and we went to the tool settings, we checked an option that says assign tool number sequentially. So regardless of what number they are in the tool, or I'm sorry, regardless of the number that they are coming out of the library, they're going to be assigned, in sequence, 1, 2, 3, 4, and so on. Once you bring in that tool, it's assigned tool number 1. We need to edit the default settings. To do that, right click on the tool. From the flyout menu, select edit tool. That brings up this dialog box. Some of the changes that I like to make on this page. The cutting length is very unrealistic. If you were to drill deeper than, say, the length of the drill tip of the spot drill, you're going to find yourself with problems. So let's set the cutting length to half the tool diameter, 0.25. And then let's set the shoulder length to 1. That'll complete the changes for this page. From here, I'll go to the next page. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, you can select the calculator. To turn on the coolant, select show more options. When the menu expands, select coolant. And then from this dialog box, let's set the flood coolant to on. I'll select OK. And that should complete all the changes that we need to make to this page. From here, I'll select finish. You can see that the spindle speed has been calculated at 1,146 RPM. It's based off of this 150 SFM, surface feet per minute. The feed rate, we're going to change the feed rate. And to do that, we're going to set the FPT. Think of it as FPR. We're going to set this to 2% of the tool diameter. The decimal equivalent of the tool is up here, 0.5. So here I'll type in 0.5 and then times 0.02. I'll hit enter. It calculates my feed rate at 11.46 inches per minute. That'll complete all the changes that I need to make here. From here, go down to the comment field. Good chance that this is empty. And what I'll do here is I'll borrow the tool name. I'll paste it in the comment field. And then all caps, drill all pilot holes. Provide some type of useful information. How's everyone doing up to this point? Okay. From here, go to the holder. We're going to use a Cat 40-inch tool holder. So right away, I'm going to go to Open Library. I'm going to select CT 40-inch. I'll open that library up. And according to the tool list, we're instructed to use a C4 C3-0032. This is a Cat 40 ER32 tool holder. And then we're going to set the tool projection. I believe it's to 1.5 inches. Yep, 1.5 inches. So tool projection is 1.5. And that'll complete all of the changes for this page. From here, go to cut parameters. I'm just checking what Mastercam has selected. Cycle is going to be a drill cycle. If you had a value in the dwell field, it would create a counterbore cycle, a G82. But because this is zeroed out, it's going to create a G81. That's what I want. From here, go to linking parameters. Activate clearance and set the clearance plane to 2 inches absolute. Let's set the retract to 0.1 incremental. Top of the stock, I'll have it set to absolute. And if you look at the coordinate system, it's sitting on top of the part. So that is Z0. If you're not sure, you can always select top of stock. And then let your cursor lock onto something that represents the top of the part. So top of stock is at Z0 absolute. For the depth, I'll set this to absolute. I'll use the depth calculator. Select the calculator. I'm going to start by selecting overwrite depth. For the finished diameter, if I click in this field, right click, from the flyout menu, select diameter of an arc. And when you do that, it allows you to go back into the graphics area of Mastercam, and you can select one of the circles that represents the diameter of the countersink. So I'll select this circle. The finished diameter is 0.425. I've got overwrite depth selected, and then I'll select OK. Tip comp is turned off when you're using a center drill or a spot drill. Make sure that tip comp is turned off. It'll give you some results that you don't want if it's left on. So from here, I'll select OK. I'm looking at the tool path right away. I see something that I don't like. After it drills each hole, or after it drills each pilot, it retracts all the way back up to our clearance plane. To fix that, I'll go to the parameters. And I'm going to select or check use clearance only at the start and the end of the operation. I'll select OK. Because we made a change to an existing toolpath that needs to be regenerated. So I'll select this icon right here, regenerate all dirty operations. You can see that the preview for the toolpath is updated. You can now see that the first hole to be drilled was over here. So we rapid to 2 inches above the top of the part, and we rapid to 0.1. We drill a hole, we rapid back to our clearance plane, Z.1, and then we move to the next hole to be drilled. Then we repeat that process until we get to the last hole, and then it rapids back up to 2 inches. So I like what I see here. Things I might be looking for, the rapid lines or the rapid moves going through the material, that could be a problem. With just that toolpath selected, I'll select the backplot icon. Zoom out a little bit. Inside of backplot, I'll have the tool visible, the tool holder visible, and the rapid moves. This dialog box allows us to control what's visible on the screen or what's visible inside of backplot. Here are our play controls. You can speed it up, you can slow it down. I'm going to slow it down a little bit, and then I'll select play. That's a little bit too slow, so I'll speed it up. Everything looks good inside of backplot, so I'll exit backplot. I'll hide the toolpath. So with the toolpath selected, I'll select toggle display. Before I go into verify, I like to look at it from an isometric view. I might fit the screen, and I might unzoom. You can also access that from the view tab. You got fit, and then unzoom 80, so you can fit it, unzoom 80. You can access this toolbar if you have the view tab selected. From here, I'll go to verify. But before I go to verify, it's always a good idea to save your work. So file, save. And now with just this toolpath selected, you could select the entire first operation toolpath group. If the stock model is selected, it doesn't matter. It will not appear inside of verify. So I'll select verify. Takes a moment to open up. Inside of verify, make sure that the stop condition collision is turned on. And then I'll select the play button. Once verify is complete, I'll zoom in and I'm inspecting the machined model. And you can see that the diameter of the countersink matches the diameter of the circle that represents the countersink. So that's what I'm looking for. I'm looking to make sure that the machine model matches the wireframe model. I think it looks good. I don't have any collisions. So from here, I'll exit out of verify. Once again, I'll look at it from an isometric view. And what I'll do now is I'll create the stock model that reflects everything that's been done up to this point. Lost my screen there for a second. Can you guys see my screen?
Yeah, looks good.
Thank you. Okay, so from here, let's create the stock model that reflects or shows us what the part will look like after the holes, after the pilots have been drilled. Make sure that the insertion arrow is at the very end of your toolpath group. Go to the toolpaths tab. In the stock section, select stock model. For the name, you can call it pilot holes or drill pilot holes. Name it something that's going to make sense down the road. So drilled pilot holes. For the initial stock shape, I'm actually going to use a stock model. I'm going to use the raw stock model. So initial stock shape, stock model. The only stock model that's currently available is the raw stock. From here, I'll go to source operations, and I'm going to select the drilling operation that we just created. From here, I'll select OK. It takes a moment for Mastercam to process it, but now you can see that the stock model has the pilots drilled into it. And if it's not quite clear what you're looking at, you can always go back to your level manager and turn the solid model level off for the moment. And you're now seeing what the part will look like after the first drilling operation. Once you verify that it's correct, I'll make the solid model visible again. I'll go back to the toolpath manager and I'll make that stock model invisible. Once again, look at it from an isometric view, and this would be a good time for me to save my work. So now that I've created the stock model for the first drilling operation, we'll move forward and let's take a look at step 2 on the project page. I'll go back to the project page, and under creating toolpaths, we're looking at step 4. Use the drill toolpath to create the holes in the part. All right. Back inside of Mastercam. Now, I'm going to show you a method that we did not use in the first two drilling projects. If I was at work doing this, I would not go to toolpaths 2D and then select the drilling toolpath, because this particular drilling operation is very similar to the first drilling operation where we create the pilots. What I can do is I can copy it, paste it, and then make a few changes to the copied one. Now you need to be real careful when you do this. When you're copying a toolpath, make sure that what you want to copy is the only thing selected. So in this case, you can see I've got stock models and the toolpath selected. I do not want to copy at this time. So left click on the toolpath. There's a green check next to just that toolpath. Once you do that, right click, and from this flyout menu, you're going to select copy. Nothing's happened. Once you copy the toolpath, you're going to go down to the insertion arrow. Make sure that the insertion arrow is at the very end of your toolpath group. You can click next to it. You'll see this gray box appear next to it. Right click, paste. And you'll see the copy toolpath now appear as operation number 4. I have 2 toolpaths that are basically the exact same thing. So I'll need to make some changes to this toolpath so that it works for the next tool. How's everyone doing?
It won't let me paste. Whenever I click on the red arrow, it like selects the last stock model that we made.
Okay. May I take a look at your screen, sir?
Yeah.
All right. Let's see what you got. Okay, so click on the drilling operation. Okay, right click, copy. And now click next to that one, the arrow. Click right there, right click, paste.
It's like grayed out because I think it selects for some reason.
You know, if you click on the red arrow and hold it and drag to the right, it'll place the gray box there. Like click and drag to the right a little bit,
Okay,
and then, but
okay, so may I take control of your screen? I want to see how it's reacting to how it responds to how I click on it.
Yeah. Okay.
Yeah, view options. I'm going to request remote control.
Am I the only one or
no, it's
Oh,
different
the
for
only
me.
one?
I'm sure you're not the only one.
Me also.
Okay. All right, so I'm now controlling your screen. Okay, so this is the one I want to copy, right? So right click, copy. And then I'm not even left clicking next to it, just right click, paste. But that didn't seem to work. Interesting. So right click, copy. And right click. It is grayed out. Interesting. Control C. Control V. I'm wondering if that's something that's not allowable in the student learning edition of the software, at least with this version of it, because that is different. It should allow us to copy that. So right click, copy. And then right next to it, I don't have a good answer for that. It's the first time I've seen that. So what we're gonna, if you're probably not the only one, how's everyone else doing with this technique?
I was able to get it to work by doing Control V without the flyout menu. So
Did it place it where you needed it to be, or did you?
so I clicked at the red arrow, it highlighted that box, and I didn't
Okay.
right click to bring up the flyout menu. And then if you do Control V now, it'll paste it.
Okay, I can. Yep. So you clicked on it, even though it highlighted the stock model, and you just did the Control V. Interesting. So let me
Pretty
demonstrate that
genius.
one more time.
Thanks, bro.
Hey, we're figuring it out. And be careful when you delete something, make sure that the only item selected. So left click, Control C, click next to the arrow, Control V. And even though the stock model is highlighted, once I hit Control V, it just placed it at the insertion arrow. So that works. And I'll try to demonstrate that again on my screen. All right. All right. So I'll give up remote control of your screen. We'll go back to mine. Slight change in our technique. So if it's working with the right click, copy, right click, paste method for you, fine, that's great. If it's not, what another method is that seems to be working. So Control C. So I selected. Now, once again, be careful. Make sure that you are only selecting the item that you want to copy. So with the green check next to just the drilling operation, Control C. And I don't even have to click next to anything because the insertion arrow is where it's going to go. Control V. Oh, didn't work in my case. Control V. There we go. So I actually clicked the stock model and then Control V. And then it placed it where it needed to be. And worst case scenario, now watch this. You can always drag these in. This is I don't like telling people to do this because it can really mess up the order of your tool paths. You can drag these tool paths around, but I don't want to do that. I'm going to actually drag this back down and then place the insertion arrow at the very end again, just so it's where it needs to be next time I need to create something. So that's a slightly different method than what I like to usually show people. there are several other methods that you can use. I just try to use the one that causes us the least amount of headaches the first couple of go arounds. So from here, once you get this new toolpath added to your tool list, or added to your toolpath list, we got to go in and we have to make some changes. So start by clicking on the parameters of the new toolpath. And that brings us to this page. Now, it's going to be a drilling operation, so that'll be fine. Now, remember, this is a copy toolpath. The reason we copied it is because the majority of the parameters or the settings are already good. The geometry is already selected. That's fine. Go to Tool. We're going to add a new tool to this tool list. So I'll go to Select Library Tool. You can see that the settings from the last time, the filter settings from the last time that we used the library or access to library are still good or still active. Select the filter icon. Deselect spot drill. And then select drill. If I go back to the blueprint, they're telling us that the hole that goes all the way through the part needs to be 0.266. Now, so let's say our model is accurate and we don't have the blueprint readily available to us, what we can do, select drill, set equal. In this field right here, you can right click from this flyout menu, select diameter of an arc. Once again, that allows us to go back into the graphics area. Select one of the circles that represents the hole that's going to the part. Now, the only drawback from this method is the model needs to be accurate. So if I select this circle, it takes the diameter value of that circle, places it in this field. I'll select OK. We filtered out all tools except tool number 128. It's a letter H drill. This is the only drill that matches that diameter value. So from here, I'll select OK. And it did not appear on my screen. Hold on, select library tool. Select it, now hit OK. There it is. So I hit OK, but I didn't actually select the tool prior. So select the tool, then select OK. The tool now appears in our tool list. We'll need to make some changes to the default settings for this tool. Right click on the tool, select Edit Tool. Let's change this. Let's set the shoulder length to 2. And I'm going to check the tool list. I want to see what the stick out length is. So the stick out length or the tool projection is 2 inches. So we need to change the shoulder length to 2. From here, I'll go to the next page. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, select the calculator. You can see that the RPM or the spindle speed is set to 2100 or 2154. To turn on the coolant, select show more options. Select the coolant. And then set the flood coolant to on. From here, I'll select OK.
Oh, before you go any further, so mine did not auto-populate with all that info. I'm like having to copy it from your screen.
Auto populate where? What are we looking at?
Like tool number.
Tool number 2?
Yeah, and like,
Okay, so did you check what tool number was it?
it was 128.
Okay, everyone else stay where you're at. Don't do anything. This is Brian, right?
Yeah.
All right, so Brian, watch what I do. I'm going to select finish, but we're coming back. So everyone else do not follow me at this point. You go to finish. And anytime that they're not coming in sequence, that's because we didn't check assign tool number sequentially under tool settings. So I exit out of here real quick and then go to tool settings. You see these items here, assign tool numbers sequentially, warn of duplicate tool numbers, and use tool step back and coolant. These are items that we set when we brought in the machine definition. Do you remember that? Still there?
Yeah.
Okay. Was that unchecked?
Yeah, I didn't have that checked or anything. I'm wondering where I screwed up.
Did you redo the project afterwards? Or did you? Because I'm pretty sure we set that because this is something we did last class. We're also talking 5 days ago. So because mine's set, I believe we did it, but I'm not 100% sure. So from here, yeah, just check all these, and that's why you're not seeing the values that I'm having. Also, what material do you have selected?
Yeah, it was 2023 or something like that. So
You got 2024 selected. So what you need to do is you need to just go to edit real quick. Change the 2024 to 6061-T6. Set your base cutting speed to 300. For the percentage of the base for drilling operations, set this to 50%. And that should be good.
got it.
All good?
Yep.
All right, cool. So from here, I'll go select OK. Select OK again. Let me get back to where everyone else is at. If I go to the parameters, right click, edit tool. And then I'll go back to this page. So the SFM, we hit the calculator and it set the SFM to 150 or something very close to it. I set my number of flutes to 1. The spindle speed was calculated by Mastercam. It should be 2,154. To turn the coolant on, I selected show more options. I'll select the coolant and then I'll set the flood to on. And then I'll select OK. Now, this should complete all of the changes that we need to make to this page. So from here, I'll select finish. Brings us back to this page. The RPM should already be calculated. The feed rate is dependent on this FPR. Think of the FPT as FPR when you're dealing with drills. Let's set this FPT equal to 2% of the tool diameter. Here is the decimal equivalent of the tool diameter. So in this field, I'll type in 0.266, multiply that by 0.02, 2%. I hit enter. And it's calculating my feed rate somewhere close to 11.46. So that'll complete all of the changes that we need to make with the speeds and the feeds. In the comment field, I'll borrow the tool name. So I'll copy the letter H drill. In the comment field, I'll paste it. Then I'll provide some additional information that could be useful to us. All caps, drill, all holes through. And that'll complete all of the changes that we need to make on this page. From here, we're going to go to the holder. Once again, we're going to use the same tool holder that we used for the previous tool. It's going to be a CAT 40 ER32. I'll start by going to Open Library. I'm going to go to the CAT 40 inch library, so CT40-IN. Open it up. And we're looking for a C3 C4-0032. Set the tool projection to 2. You'll see this image update. Everything looks good. Other things that we need to check. Go to cut parameters. It should have changed over to a PEC drill cycle with the PEC increment equal to the drill tip length. This is something that Mastercam is calculating for us. Once again, where it says tool settings or under tool settings, we checked assign tool number sequentially. The other option was use tools, step, PEC, and coolant. So Mastercam is pulling up these values for us. From here, I'm going to go to the linking parameters. Now, because this is a copy tool path, the majority of these settings should be good. what we need to do is we need to change the depth that we're drilling to. This hole is being drilled all the way through the part. So if I select the depth icon, it allows me to get back into the graphics area. I'm going to pick select something that I can lock onto that represents the bottom of the part. So I let my cursor lock onto this endpoint. Be careful. It needs to lock onto something. You need to see it happen. Once I see it lock onto the bottom of the part, left click, and then it takes that Z value relative to the origin and places it here. Now I got to ask the question. If I drill to a depth of Z minus 1.0, will the full diameter of the drill go all the way through the part?
No.
No.
Oh.
We need to take into consideration the length of the drill tip. So when we tell it to go to a specified Z depth, the drill tip is going to that Z depth. We need a full diameter going all the way through the parts. We need to go a little bit deeper. Here is where the tip comp option becomes helpful to us. So select tip comp, activate it, set the breakthrough amount to 0.025. That's the additional amount that you see the drill or the edge of the cutting or the cutting edge where the full diameter begins to the bottom of the part. So this is an additional amount that we're going to send it to go or drill through the part just to guarantee that the full diameter goes all the way through. The tip length, Mastercam is doing the calculations for us. It's based off of this 118-degree drill tip angle. And from here, I think that's all the changes that we need to make. I'll select OK. In this particular case, it was a copied toolpath that we had to make some changes to. So we'll need to regenerate it. You see the red X next to it? Come up here, you can do one of these two options. In this particular case, regenerate all selected operations. This is the only selected operations. So if I select this icon, you can see it update. Once it updates, I want to run just this toolpath inside of Backplot. So with just this toolpath selected, you can see the green check next to it. I'll select the Backplot icon. You see a preview of what the toolpath will look like. I can select the play button. And you can see that the toolpath goes all the way to the bottom of the part. Something that I will do, if I look at it from a front view, right click, and look at it from a front view. I'll change over to a translucent view. And then if I hit the B key, now remember, I've already run Backplot. So now I'm backing up. And I'm just zooming in. I want to make sure that the full diameter of the drill is breaking through the bottom of the part. And that looks good. So from here, I can exit Backplot. I can look at it from an isometric view, fit the screen, unzoom 80%. And before we go into verify, I'm going to save my work. Prior to going into verify, make sure that you have all toolpaths selected. A quick way to do that is just select the first operation toolpath group. Once you select the toolpath group, you see a green check appear next to everything within that toolpath group. So with everything selected, I'll select verify. Once inside of verify, make sure stop condition collision is turned on. And then I'll select play. Once verify is complete, you want to inspect the model, make sure that the machining or the machine model is correct. I don't have any collisions. It would have stopped. And you can see that the full diameter of the drill is going through the bottom of the parts. And that's what I want. So from here, I'll exit verify. I'll save my work. And the next thing we'll need to do is we'll need to create a stock model that reflects everything that we've done up to this point. So now that we've created the second drilling operation, we need to create the stock model that reflects everything that was made up to this point, or everything that the machine is doing up to this point. So make sure that the insertion arrow is at the very end of your toolpath group. Go to the toolpaths tab. In the stock section, select stock model. On the first page, let's say drill all holes through. Something like that, something that makes sense. For the initial stock shape, we want to use the stock model that we created from the previous operation. So from the stock model drop-down menu, select drilled pilot holes. That'll complete all the changes that we need to make to this page. From here, go to the source operations. For the source operations, select the drilling operation that we just created. From here, I'll select OK. It takes a moment for Mastercam to process the stock model. Now, it's very difficult to see at this time. Reason being is the stock model matches the solid model that represents the part. And what you can do is you can go to the level manager and toggle off the visibility of the stock model. Oh, I'm sorry, toggle off the visibility of the solid model. And you can see what the stock model looks like. This is what the part's going to look like inside of the machine at this time, after the second drilling operation. I'm comparing the stock model to the wireframe representation of the part. Everything looks good. So from here, I'll make the solid model level visible. I'll go back to the toolpath manager. I'll toggle off the visibility of the stock model. And the next thing we'll need to do, let's go back to the project page. Step 5, use the contour toolpath to create the engraved initials on the part. If I scroll down to the very bottom, tool number 3 is a 1/32 diameter ball mill, 2 flute. We're instructed to use the C4C4-0016 tool holder, and the tool is only going to be sticking out of the tool holder 0.5 inches or half an inch. So from here, go back into Mastercam. To engrave the initials, I need to see the geometry that represents the initials. So I'll go to the level manager. I'll make my name level visible. Now the color that I chose is a little too close to the color of the solid model, so it's difficult to see. But I can see it well enough, so we'll leave it the way it is. From here, I'll go back to the toolpath manager. I'm actually going to turn off translucency too. That makes it a little bit easier to see. Maybe not. Okay, right there. I'm going to go to the contour toolpath. So make sure the insertion arrow is at the very end of your toolpath group. Go to toolpaths. In the 2D section, this time we're going to use contour. I'll select contour. That brings up the wireframe chaining dialog box. The mode is set to wireframe. I'm going to change to 3D. And then for the selection method, I'm going to use window. So wireframe mode, 3D, selection method is window. I'm going to create a window around my initials. You want to make sure that you capture all of your initials. It doesn't look like anything has changed, but you'll notice that this prompt has changed. It says sketch approximate start point. I'm going to select the bottom left endpoint of my first initial. Let my cursor lock onto it, left click. Once I do that, everything becomes selected. From here, I'll select OK. And that brings up the parameters for this toolpath. Now, because we're engraving with a contour toolpath, there's a lot of things that we need to turn off. But before we do that, let's talk about the tool that we're going to use. Go to Tool. I'll select Library Tool. Now my filter is still active, so I'll go to filter. I currently have all tool types turned on. I'll start by selecting none. Turn off all tool types. I'll select end mill to sphere. For the tool diameter, we're looking for a small tool. So what I did is I set it to less than 0.125. And then I'll select OK. I've only got 3 tools that match the description that we defined. And what we're doing is we're looking for the 1/32 ball end mill. In my case, it's tool 301. If I double click on this, it should be added to my tool list as tool number 3. Once you add it to your tool list, we'll need to make some changes to the default settings. Right click on the tool. From the flyout menu, select edit tool. And the first thing that I'm going to change is the overall length. This is a very unrealistic representation of this tool. So let's set the overall length to 1. And we'll leave everything else the way it is. From here, go to the next page. For the number of flutes, let's reference the project page. It says tool number 3 is a 1/32 diameter ball mill, 2 flute. So set the number of flutes to 2. That's 2 cutting edges. If you calculate the RPM, select the calculator. It's maxing out as what we set as our machine's capabilities, our maximum capabilities. To turn on the coolant, I'll select show more options. I'll select coolant. I'll set the flood coolant to on, and then I'll select OK. And that'll complete all of the changes that we need to make to this page. So from here, select finish. Brings us back to the settings for the RPM and the feed rate. You can see that the spindle speed has already been calculated at 10,000. To calculate the feed rate, set the FPT. Now this is a end mill, it's not a drill, so we're going to use a slightly smaller FPT. We're going to use a 1% as our multiplier. So FPT, set it to 1% of the tool diameter. Here is the decimal equivalent of the tool, so 0.03125 times 0.01, 1%. It's calculating my feed rate at 6.25. Now with end mills, the feed rate is referring to how fast it's moving when it's moving in the XY plane. The plunge rate is how fast it's moving when it's moving in the Z axis or along the Z axis. I like to set my plunge rate I set it to half of the calculated feed rate, so this value. So what I'll do in this case, 6.25, divide that by 2. Once you calculate the feeds, we need to provide some type of comment. So tool name, I'll borrow the tool name, paste it down in the comment field, and we'll say engrave. No, this needs to be in all caps. So engrave initials. That completes everything on this page, all the changes that we need to make on this page. From here, go to cut parameter. I'm sorry, go to the holder. So from the tool, go down to the holder. Once again, we're looking for a Cat 40 inch tool holder. So I'm going to go to Open Library. I'm looking for CT40-IN. Open that library up. And according to the tool list, we're looking for a C4C4-0016. It's right here, C4C4-0016. Select it. And the last thing we'll need to do on this page is set the tool projection to 0.5. From here, go to cut parameters. When you're using a contour toolpath to engrave, there are several things that you're going to need to do. You're going to need to turn the compensation type to off. So compensation type, set it to off. Contour type is 2D. Stock to leave on walls. I'm gonna set this to 0. If you already have 0 there, you're good. Depth cuts. I'm turning depth cuts off. We're only engraving to the depth of, or to a depth of 0.005. We don't need depth cuts. So I'm turning depth cuts off. Lead in, lead out. Turn this off. So select it, uncheck, lead in, lead out up here. And you'll see a circle with the diagonal line appear next to it, a red circle with a red diagonal line. Breakthrough. Want to make sure that this is off. So if you select it, uncheck it, you'll see the circle with the diagonal line. Multi-passes, make sure it's turned off. Select it, it's unchecked. You can verify that with the circle with the diagonal line. We're not using tabs in this class, so all of these are turned off. Go to the linking parameters. Let's use the same settings as the previous 2 toolpaths. So set your clearance plane to 2 inches absolute. I'm going to check use clearance only at the start and the end of the operation. Retract, I'm setting this to 0.1 incremental. Feed plane, I'm going to set this to 0.05 incremental. Top of the stock, I have it set to absolute. I'll select the top of the stock icon. Allows me to get back into the graphics area. I'm going to left click on something that represents the top of the part. And it should be set to absolute 0. For the depth, set that to absolute. Now, what I'm going to do, because I know it's at 0, I could just type in minus 0.005 here. There'll be situations where it's not at 0. So what I would do in this case, or in that case, I'll select the depth icon. Once again, let my cursor lock on to the surface that represents, or the surface that's going to be engraved on. So 0, and then I would type in minus 0.005. And that's the depth that we're actually going to engrave to. So hit enter. So my depth is minus 0.005 absolute. And that'll complete all of the changes that I need to make to this toolpath. From here, I'll select OK. Zooming in, you can see we rapid to this point. So the yellow lines represent rapid moves, the green lines or blue lines represent feed moves. I'm not seeing anything that's causing a problem yet. So from here, with just that toolpath selected, I can run back plot. I'll select play. I think that looks good. So from here, I can exit backplot. I can toggle off the visibility of that toolpath. Once again, fit the screen, unzoom, save your work. And then let's run it and verify. I'm going to select the entire first operation toolpath group. I'll select verify. Once inside of verify, make sure that the stop condition collision is turned on. And then select play. I'm zooming into my initials. This is the new machining operation. And what I'm looking for, I want to make sure that the wireframe geometry that's driving that toolpath is centered on the machined initials. And it looks pretty good. So the machine model looks good. I don't have any collisions. Something else that we can do while we're inside of verify, we can save the machined model as an STL file. We can actually send it to a 3D printer if we want to. In this case, we'll save the STL file. To do that, so once you're done machining the part inside of verify, you're gonna go to the Verify tab. So you're inside of Verify, select the Verify tab. And on the far right side of the screen, you'll see Save Stock as STL. So I'll save stock as STL. And I recommend saving this in the working folder. So if I go to my class folder, so Fall 160, Drill Project 3. And I'll just call it Drill Project 3 and maybe even type in complete on the tail end of it. So Drill Project 3 complete. And it's going to save it as an STL file. And it's saving it to the working folder. I'll select save. Sometimes it takes a moment to do this. And depending on the computer I'm working at, I might jump back in the Mastercam while this is processing, because sometimes it could take a moment. But I find that having Verify open and Mastercam open at the same time, it can slow down my workflow. So what I usually do is I like to use Verify. When I'm done using it, I exit out of Verify. And you can tell that it's still saving it by this progress bar down here, and then I've got that progress wheels next to my cursor. And it's always a good idea before you save the STL file or before you exit Verify, just make sure everything looks correct. All right, so now that it's done saving, I'll exit out of Verify. We need to create a stock model that shows the completed part. I've got the insertion arrow at the very end of my toolpath group. I'll go to toolpaths, stock section, stock model. And this one we could call completed part. For the initial stock shape, I'm going to select the stock model that we created with the previous operation. So drill all holes through. And then from here, I'll go to the source operations and I'll select the contour operation where we engrave our initials. Select OK. Takes a moment to process. And if you zoom in, you can actually see the initials engraved into the stock model. It might be easier to see if you go to the level manager, turn off the solid model. You might even turn off your initials. And now if you zoom in, you can see the engraved initials on the stock model. Everything looks good. So from here, I'll just make the stock model, I'll make the solid model visible again. I can make the name invisible again. And then I'll go back to the toolpath manager and toggle off the visibility of that stock model. Look at it from an isometric view, fit the screen, and then unzoom by 80%. We need to create a setup sheet. And before I create a setup sheet, I like to look at it from an isometric view, because you will see the orientation of this part or the orientation of this view in the setup sheet. So let's minimize these, make more room inside of the toolpath manager. To create the setup sheet, in an open area of the toolpath manager, right click. From the flyout menu, I'll select setup sheet. Sometimes it takes a moment to open up. Maybe I didn't hit it. So right click, setup sheet. Oh, something that I don't think it matters, but I didn't select everything. Yeah, I think it does matter. So selecting, before you select, right click and select setup sheet, select the machine group. So I'm selecting Haas VF2. And that way it guarantees that everything is selected. And then right click, setup sheet. There we go. So reason it didn't work is I only had the stock model selected. So select the entire machine group for the project. Let's call this drill project 3. The customer is going to be San Diego City College. The programmer is going to be you. So put your name. Accept the default settings for everything else, and then select OK. It'll do its thing. It takes a moment, and then it's going to open up the viewer. So active reports viewer, and you can see page 1. It shows us where the file is located. It's got some other information that's very useful. It shows us an isometric view of the part, where the origin's at. Here's our material. It's showing us what tools are being used. This is very useful when we send the program out to the setup guy. They'll reference this information. So this all looks good. Once you create the setup sheet, you want to save it as a PDF. So what you'll do is you go to File, Save As, Portable Document Format. And you're going to save this to the working folder. So drill project 3. I'll call it drill project 3 setup sheet. File saved. Once it's saved, I like to verify that it's saved in the correct location. So I'll go to the working folder, drill project 3. And in this folder, you can see the STL file that we created from Verify. You can see the setup sheet that I just generated. You can see drill project 3. This is the big item right here, the Mastercam file. And then you can also see an NC file, but this is that NC file where I was just demonstrating, where I was showing you guys some of the components inside of the NC file. So we're going to redo this one. So I'll minimize this. I'll close out of the active reports viewer. The next thing I need to do is I need to create the NC file and the NCI files. To do that, make sure all tool paths are selected. Select the G1 icon. This post-processing dialog box will appear. Check NC file and NCI file. I'll select OK. It's asking me where I want to save the NCI file and what the file name is going to be. So I'm going to leave it at drill project 3. It's saving it in the correct location. I'll select save. Now it's trying to save the NC file. Once again, make sure it's saving it in the correct location. And we'll call it drill project 3 NC or .NC. I'll select save. It's asking me if I want to replace it. I'll select yes. It's going to open up Code Expert again. And looks good. Now this is the Code Expert converting the graphical representations of the toolpaths into a language that the machine will understand. And once you verify that it's all there, you can close out of it. If I go back to my working folder, I want to double check, make sure it has all the correct files that it needs. So you guys will not be able to create the NC file or the NCI file because you're working from the home learning edition of the software. But you can create the STL file inside of Verify, and you can create the setup sheet, and you'll definitely want to make sure you turn in the Mastercam file because that's the majority of what we base your grade on. Everything we need, the majority of what we need is inside of the Mastercam file. So I verified that everything is correct or everything's where it needs to be. So from here, I'll close out of File Manager. I'll save my work one last time. And that's going to complete drill project 3, or that'll complete the drill project 3 project.